Okay, hello. Today we're going to talk about partial derivatives, and this is problem number 11 on page 819 of Thomas's Calculus 13th edition, Early Transcendentals. And our goal is to find df dx and df dy. And you can notice that these are not the normal these are little deltas, and that means that we're going to be taking partial derivatives. As you can notice, f is a function of x and y now, so it's a multivariable function. So in this case, in this example, we look at this function here, and we notice that if we're going to take the derivative with respect to x or y, we're going to have to use the quotient rule. And we know that because there's an x on the top and the bottom, and also a y on the top and bottom. So in order to do this, actually, before I go into that, we want to note that multivariable functions follow many of the same rules that single variable functions do when you're differentiating, such as the quotient rule, the product rule, the chain rule, etc. Okay, so we want to just look at the quotient rule first. So we're just going to look at this in general in terms of, let's say, a single variable function. So quotient rule. So if we want to find the derivative of a certain function where on the top you have a function and on the bottom you have a function, such as this, so that like our quote-quote top function is going to be x plus y, and our quote-quote bottom function is going to be xy minus 1. In this case we're talking about single variable functions, but since it's the same process, it doesn't really matter. In this case we're talking about single variable, but that's okay. So it's going to be the derivative of the first times the second minus the first times the derivative of the second all over the second squared. So I'm just going to clean up one little thing here. Where's my eraser? Okay, that is f prime of x. I just want to make it clear here. F prime of x. Okay, derivative of the first times the second minus the first times the derivative of the second all over the second squared. So in this case, we want to take, we're doing that but with respect to y. So let me change the color here so we can follow it better. Excuse me, we're taking it with respect to x first. So df dx. Now in multivariable functions, whenever you're taking the derivative with respect to one variable, all other variables are considered constants. And it's essential to remember that when you take the derivative of a constant, it goes to 0. So let's look at this. So according to the quotient rule, derivative of the first, which is our top here, x plus y, the derivative of that with respect to x, the derivative of x with respect to x is just 1. The derivative of y with respect to x is 0. So plus 0. That's what we're talking about. Y is considered a constant when we're differentiating with respect to x. So it goes to 0. So that's the derivative of the first times the second. That's going to be our xy minus 1. Okay, so now minus the first, which is going to be x plus y. And now we want to do the derivative of the second. So remember, it's with respect to x. So in this first term, we have an x and a y. Now, we're considering y as a constant. So it's just as if you were taking the derivative of, let's say, 2x. If you were to take the derivative of 2x with respect to x, it's just 2. So in this case, when we're taking the derivative with respect to x of yx or xy, it's just going to be y. And now we're moving on to the constant part. Take the derivative of constant, it's going to be 0. So it's going to be minus 0. Okay. And then that's our first part up here. Now we're going to the bottom, which is just the second squared. So that's going to be our, oops, doesn't really matter that I write that first, but I'll just stay consistent. xy minus 1 squared. And we're going to simplify this a little bit. So over here, all we have, that's just 1. So we have that xy minus 1. And now we have minus x plus y quantity times y, essentially. So it's going to be minus x times y minus y squared. And then we're just going to keep the bottom as is. And we can just do one more simplification. These xy's cancel. So we have negative 1 minus y squared over xy minus 1 squared. So that's our the derivative of f with respect to x, df dx. Another notation for this is f sub x, and also for this one, this would be f sub y. Okay, so now we're going to do the same exact process just with respect to y. So when we're taking with respect to y, all other variables are considered constant. So in this case, x is going to be considered constant. So let's look at that. df dy. Okay, so we're going to follow the same quotient rule just as before. So the derivative of the first with respect to y. The derivative of x with respect to y is 0 because x is considered constant, and the derivative of a constant is 0. We're looking at the second, the derivative of y with respect to y, that's just like we're doing like normal. That's just going to be 1. Okay, so now that's the first part. That's this term right here. So now we're going to do it times the second, which is going to be xy minus 1. And then we're going to do minus the first, which is just x plus y, times the derivative of the second. Now in this case, we're taking it with respect to y. So the derivative of xy with respect to y, x is considered constant. So just like before over here where we just took y as a constant, in this case x is going to be constant. So the derivative of xy with respect to y is just going to be x. And similarly, the derivative of negative 1 is just going to be 0. So it's going to be minus 0. And that's all going to be over the bottom squared. So that's just following the quotient rule. Okay, so we're going to simplify this just like before. So this is 1 times xy minus 1. So we're just going to have xy minus 1. And now we have x plus y times x. And that's all going to be negative. So it's going to be negative x squared, so minus x squared, and then we have a minus y times x, so that's going to be minus y times x. And that's all going to be over xy minus 1 squared. And again, we can simplify even more. We can just cross out these xy's, so we're going to get negative 1 minus x squared all over xy minus 1 squared, and we are done with that. So the main points to take out of this are that multivariable functions do follow the same rules as single variable functions when you're differentiating, and when you take the derivative with respect to one variable, all other variables in that multivariable function are considered constant, and you're going to follow those same rules. Have a good one.